Hey everyone, Maske here. In today's video, I'm going to show you how to make the character shoot, calculate the shooting line, camera transition when aiming, and spawn a shell in Agra Effects. If you enjoy this topic, make sure to leave a like, subscribe to the channel, and let's get started. This video is a continuation of the motion matching animation series that I'm showcasing here on the channel. So, this is the third episode of the series, and I'll leave the links below in the description. If you haven't seen the other videos scope and want to follow along with this tutorial series, check them out here later. To start, let's change the input for equipping the weapon. Go to the Input folder and open IMC Sandbox. Here in the IM option, where it says right mouse button, click and press the number 1 on the keyboard. This way, we will map the number 1 key to equip and unequip. Click Save and you can close it. Returning here to the blueprint, when we now press the equip button, which is the number 1 on the keyboard, it will perform the same action that was on our right mouse button. Thus we have a free right mouse button. Now click on Viewport and let's select the static mesh of the pistol. Double click on static mesh and let's create a socket here. Name it muzzle flash. It's a somewhat standard name, so let's use it. Take the opportunity to copy it. F2, it will select the name, and then you click Ctrl+C to copy. Here we will zoom in the camera. Click here in the corner, and let's decrease the speed. This way it's easier for us to zoom in and correctly position the socket, and we will place it right at the front of the weapon, as this is where the shot will come from. Click Save and you can close it. Go back to the character blueprint and click on Open Event Graph. This way we return to the coding part. Here on the left mouse button is our shot. So we want something called line trace by channel to happen. It serves to direct as if it were a shot. It will trace a line to your target and check if the shot hit or missed. So here, after executing the animation, we need to create a notify. Thus, the notify, when executed within the animation, will inform that blueprint to execute that code. Let's pause here. And right here at 0, in notifies, where the number 1 is, right-click, add notify, type montage. And here we will put attack. Take the opportunity to copy Ctrl+C. You can save. Let's go back to the blueprint. In on Notify Begin, look for and switch on name. Turn on Notify Name bar with the selection option. Click on Switch on Name, add the new pin name, and paste the name we created. And uncheck the Has Default Pin option. Compile and save. At this point, the shot is probably already firing. Let's do a test. Bang! Equip the weapon. Bang, 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 bang. Alright, it's working. Now we need to create the trace. Pull the static mesh of the pistol, which is up here below the mesh, and let's use that socket as a reference. Type socket, and let's get gate socket transform. The socket we named muzzle flash. It's better to copy from there to avoid errors. Let's go back here in viewport. Click on pistol, double click. Select it, F2, Ctrl C. Go back here in the blueprint in the event graph and paste the name. This way it ensures that it will use the correct socket. On return value, right-click, split, struct pin. This way we have the values for location, rotation, and scale. Let's pull. Location, and search for line traced by channel. You can see that it already connects with the start option. It's the correct option. This is the one we're going to use. Pull it a little over here, and let's connect the attack here. In other words, as soon as the attack is triggered by the notify, it will perform the line trace by channel. Let's pull it a bit more over here to have a little more space. And pull it a little further forward as well. Here in rotation, look for get forward vector. This means that we are taking from the location where the socket is. We are going to get the position where it is facing forward. From this position, we already know where it would be looking, so to speak. So we want to trace a line from the point where it is, facing forward, to our target. Let's say a shot will travel 2000 here in Unreal's calculation. So we are going to do the following. Pull from the return value downwards and press the multiplication key on the keyboard. We are going to call the multiply. Right click and select the option to float single precision. This will convert it just to float, meaning it would be 2000 in distance, so to speak. This will be the distance that it will calculate frontally. For us to have the final objective, the line trace needs to know, okay, you have 2000 in distance, but starting from where? And it starts from the same location up here. So from this location, we draw a new line. Click the plus key and select add and connect to the 2000 node with this addition node. Now we have our endpoint. In other words, it has the starting point, which is the socket location. And from the socket location, looking forward, it will project 2000 points ahead. This will be our target. In visibility under trace channel, leave it as visibility. What is visibility? There are two options here, visibility and camera. I'm not sure if you can see it clearly. I'll maximize it. Well, it stays the same size. There's visibility and camera. What does this mean? Here in the character's viewport, or rather, on the character itself up here, sandbox character, in details, type call for collision. Here in visibility, we have visibility and camera. These are the same options we have in the line trace. So if we set it to camera, it will look through the camera, or visibility through visibility. Since we want it to hit something, to collide with something, we will remove visibility and set it to block. Otherwise, it would be ignoring the collision. And we need it not to ignore, but to block. Compile. Returning to the event graph, we have a few more options. Here in Draw Debug Type, click and select for duration. This way, it will trace the line and keep it on the screen. It will just be easier for us to follow at the beginning. Now our shot is probably already working. Shall we make the code a bit cleaner? By selecting this entire new part, right-click and select Collapse to Function. This way, it will create a new function and clean up our code a bit more. Let's rename it to line trace target. All set. If we want to change anything in it, just double click. And it's right here. It's important for us to work with functions because we can call them from other places, as in the future. It's not just our character that will use this type of line trace, but also the enemies. This way we can use the same function. Click on compile and let's test it. Press 1 to equip and it's already working. Notice that when it passes through something, the color changes. So those green traces are after it has collided with something. The red trace is the initial one and the green is like the result. If it doesn't collide with anything, it will always pass in red. If it collides, it will come out the other side as green and mark the collision point. Let's make a few more modifications because our character isn't keeping up well with the camera movement as we're aiming. Let's make this a bit more dynamic. In the character blueprint, click here on Sandbox Character and look for Wants and check the Wants to Aim option. Normally this option is unchecked. Make sure it is checked. With this, our character will turn a bit faster. But it's still slow, it's still not the way we want it. Let's make some modifications here in the animation blueprint. We already have an animation in a blend per bone layer. It will mix the upper part with the lower part. Let's copy this part and place it here in front. Stretch this one a bit, which is the result, and place it here. Let's save a position after this trajectory. Type save, press enter, and put traject. I typed it wrong. Trajectory. Here, use traject, which will be linked to the bone pose, to the base pose. Copy, paste, and connect it here below again. And as a result, we connect it up here. Compile, and let's test. Now it's already faster. It perfectly follows the camera's rotation. Now we already have a much better shooting game. There is still a situation with the turning in place. If we slowly turn the camera, it will follow. But if we turn quickly, we can circle around the character. This is one of the little things that happens with turning in place. There are some settings we can adjust to avoid this, but we won't cover that in this video. Let's move on to the aiming function now. Let's create a new input. Click on any one. Press Ctrl D to duplicate. And let's name it. The other one we have named aim. Let's name this one equip. Equip on equip. Double click on the EMC sandbox icon. Here in mappings, click on the plus sign. And let's look for equip unequip. It already appears here. We had changed the aim to the key one. Let's change it back to the right mouse button and assign the key one, nom, to equip unequip. Click on save. Back in the character blueprint, we will make changes here, just as we called the enhanced input, action. Here for aiming, we will call it for equip. Equip, unequip, and save. And let's put it in its place. Here in started. We connect here. Let's disconnect. This note. We are going to use it for aiming. So move it a little bit forward here. Another good practice is paio, to always aim. Place them in cards. by selecting All and pressing the C key. A card appears that will encompass all the nodes. Here we can put a tag function. Another good practice is to always try to use variables and names in English, as it's kind of an industry standard. To create this zoom function, we will apply it directly to the camera. The variable we want to access is this target arm length, and we are going to modify it. So drag the spring arm to the blueprint, set, target, and select set, target arm length, and connect it with the started node. If we set a value here that is smaller than what it currently has, it's at 300, which is the distance. It is from our character. Move the camera closer here. This here is a distance of 300. Going back to the event graph, if I set it to 150 here, when I trigger this function, it will change the distance in the game, right? I can't go back because I haven't made the return function yet, but this is the zoom function. Notice how fast it is. Ideally, we should create a transition here. So let's cut this node for now. Drag it a little further here. And let's use the timeline function from started. Pull the node at timeline. Let's name it zoom camera. In update, connect it with the E target arm length node. Double click on zoom camera and click here on track to add a new track. In length, let's set it to 0.2, which will be the duration of our transition. Click at some point here at the beginning, right click, add key to curve float. Here we'll set 0 and 0 for initial values. Click again, add key to curve float, and we'll set it to 0.18, and here set it to 1. Then click on these two buttons, the first and the second. This way, it will already give us our curve view. This here is roughly how our animation will follow. Click on compile, and let's return to the event graph. Now we will connect the new track 0 here to the target arm length. And we will connect the completed to the reverse. What does this mean? When it starts, it means it will switch to zoom. And then, when we release the button, it will trigger the completed and reverse the difference we set. In other words, undo the zoom. Oh, I forgot one more point. Here, we need to call lerp, which is where we will set our zoom in and zoom out points. Bring it to the last line in alpha, so that we have these 2 points. And here we will make the transition from here it's 300, which is the current value, to 150. And now, yes, we make this connection. Done. Now it should work. While I hold the right mouse button E, it will apply the zoom. When I release it, it returns to normal. Let's take the opportunity to adjust this camera a bit, to give a better feel. Let's move it more over here, maybe a bit higher. Let's test it. Looks cool, huh? Let's add the weapon. Aiming. The sight appears. With this, we can even add a reticle function later, which is that little dot in the middle of the screen that opens and closes. And normally when aiming, the shots are more accurate. It shoots straight or like this, because we need to add an offset function, so it looks up and down. Even if I do this, the IIII character is not configured in the animation blueprint to execute this. I will teach this in another tutorial as well. Let's implement more things. Go to the Pixabay website and type pistol. And let's get a gunshot sound here. Download it. Open the folder on your machine and let's drag it into our project. Let's select the weapons folder. Weapons creates a new folder here. Sounds. And drag the sound here. Save everything. And we already have sound in the game. Great. Let's go to the animation and pause it. Add the new notify track, and at the same point where it fires, click on add notify and type play sound. It even brought in that sound we just added, right? Let's see how it turned out. Looks great. Let's save and see how it looks in the game. Equip, gave that zoom. It seems like the sound is a little delayed, right? Well, I'm still not satisfied. I want to add some lighting effect when we fire the shot. Let's go to the line trace target and make use of this muzzle flash socket. In location, drag and search for spawn, emitter, at location. Let's make this a little nicer here, because it will get quite messy if we leave it like this. Pull it over here. Let's place this one below. Let's connect the line trace directly to it and connect it to the line result. Here, let's look at the options. There's this explosion. Since this is an original third-person template, it doesn't have many particles. So let's use this explosion one. It's not suitable, but it will serve the example. Since it's quite large, let's set it to 0.05 here. I think it will look somewhat good. Ideally, you should really use a flash particle because even the speed makes a difference. The explosion is a bit slower, so it won't give such a cool effect, but you'll be able to see more or less how to make it appear. Let's test it. The show zoomed and equipped. That's it. When we are executing, you can see when we drag, the animation is still there because it's not the right animation. But if we were using a flash animation, it would be faster and wouldn't give this kind of smoke effect. You wouldn't notice that the character moved, but you can already get an idea of how to make the muzzle flash. This is a faster way. There are other ways, like putting it in the animation itself. I don't know if you are already tired, but I want to add one more thing. This one is going to be a challenge for me. I want to make the shell fall like Niagara. Yes, we are going to use types of effects to make this shell fall. Let me look for the weapons here. The weapons folder, closing it will make it easier. Here in the weapons folder, let's create a new folder called effects. Inside it, right-click, Niagara system. Let's start from scratch. create. Let's name it NS_NS for Niagara system. It's always wise to name the file with the initial of the type of system it represents. Let's name it shell, eject, shell out, anything like that would work. Let's bring it here. Let's close the sandbox. Here, first click on NS shell eject and let's set it to once. What does this mean? It means that I don't want it to loop infinitely. I want the animation to play just once. And here it should also last once. If I set it to infinite, it will always play once infinitely. And here it will play once just once. I don't know why it exists this way, but that's how it has to be. In the other option, we need to add some things. Since this animation is clean, we have to create it from scratch. Let's start with the update. Let's add the burst. Look for the option spawn burst instantaneous. Add, and here on the side, click on fix issue. Leave it as 1, which means it will spawn only one material. We will select this material later. If we wanted to spawn multiple capsules each time we shot, we would just increase this value. We want just 1. Now let's go to the spawn. Now here, let us start initialize particle. Initialize particle. Lifetime is the duration that this particle will remain on the screen. 5 seconds will give it time to leave the weapon, hit the ground, stay there for a bit, and then disappear. If you want to set more time here, you can do that too. And there's another option which we will add later where it stays forever. It never disappears. But remember that each time this spawns, it will consume a bit of your memory or a bit of your VGA memory. So it's important not to have too many things on the screen. Niagara basically uses the processor to generate all the effects. So it has a slightly lower impact on your graphics card. Let me see the next step. After it initializes the particle, you need to add velocity. This here will be the speed at which it will exit the weapon. Fix issue. Here in velocity, click on this arrow and type random. And let's select the first option, random range vector. Why is that? Well, because it will always spawn in the same place, but it won't always go in the same direction. Our intention is for it to go in different directions so it doesn't look too mechanical. Let's put here -20 at minimum, -20 as well. And here at 20. Here, put 50, 40, and put 100. Why? I don't know. I learned it this way and I use it this way. I believe it's the positioning from which it will be fired. There are more things for us to set in this particle spawn here. Yes, we need to define the orientation. So I think it's mesh orientation is that initial mesh orientation. Here we are going to set it to system and enable rotation. Here, what does it mean? It will be a capsule. This capsule needs to always come out facing where it was shot from, right? It would make more sense. Let's set it to 90. 90. If we don't set this orientation, it will spawn sideways, upside down, so it won't make much sense. So it's important that we set this orientation. With that, I think the particle spawn is finished. Let's move on to the update. Here we are going to start with the particle scale. It should be up here. Did I type it wrong? It's not scale, it's state, particle state. This is where it indicates that the particle will die after a certain time. If you deactivate this option, it even gives a warning. Want to see? Yeah, Here, look, unchecking this option will cause the particles to live forever. So it's what I mentioned about consumption. In the next step, we will need to carefully update the mesh. Please update mesh orientation, which is this first option. Here, right, yeah, we want this capsule to fly, so we can mark it as flight orientation, so that it is as if it were spat out, you know? It will be pushed in a way that it is thrown into the air, so it is called flight orientation. Let's add one more here. We need to add a bit of gravity so that after it is spat out, it falls to the ground. Fix issue. And leave it as it is. Let's use the standard. And let me see. State, gravity. It has to hit as well, so we need the collision. Collision, something like that. The only thing we change here is that the calculation of the collision, we don't want it on the sprite, we want it on the mesh. So we want the capsule itself to collide with the environment. And now the last render option, we need to add a mesh here. It doesn't appear on this list, but no problem. It does appear. Here it is, look. Mesh render. And in this option, open here in meshes. And here we will select capsule. Type shell. And let's select this 9mm empty. This capsule will already be in your project because it is from that free weapon pack we added in the first video. So select it. And I believe that's everything here in the Niagara effect. So this is, I think it's the first Niagara particle I'm making on the channel, if I'm not mistaken. It's this one here. Now we need to put it in the animation here. Right. Create a new notify track. Right click and select Niagara particle effect. It should come out with the attack, since the sound should come out first. Here we select shell, which is the name of the one we created, shell eject. And here, it has a peculiarity. We can't just place it in the air, because it's coming from the ground, you see? I don't know if you can see it on the ground. Right here, look. And the idea is for it to come out from where the weapon itself is. We could do this the same way we did this part here. It's also interesting. Let's do it here, let's try it here. I haven't tried doing it here yet, but I think it's the best place. Let's type shell. And here we created a socket. Oops, let's reduce the camera. Here we create another socket and position it wherever we want. Let's place it here, look. So the bullet exit will be here. Right? A little further forward. And in the middle. Good. So when we call this spawn, it will spawn from here. Go back to the blueprint. Here we need to add the Niagara particle. Click on the pistol, click on add, type Niagara. It will already appear up here. And will even take the name of our particle. And it will come already selected. Things from Unreal. The good part, right? Drag it here to the graph. And in it, we will pull spawn system attached. From here, let's say that first the capsule comes out and then the explosion will follow, which would be the muzzle flash. And let's drag this a little bit more to the side. That's how codes grow, right? We start with a small code, something practical, then add a little more, and before you know it, the code is huge. But that's how it is. Drag it here. Drag it there. Leave it like this. This is good. Here in the attach point name, we're going to put the name of the socket we had set earlier, which is shell. The same socket from here, we're placing it here in the blueprint. And mark auto destroy. And I think that's it. This is the easiest way. Zoom in, equip the weapon. Bang, 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 bang. And look, it's not showing up. How nice. Why? Oh, of course, I didn't select the shell particle here. Now, yes. Compile. Zoom. Equip. See? And these shells, they will stay on the ground for 5 seconds. And they start to disappear. Now it's better, you think, right? Just to add, I'll show what we would need to do at this point to solve the socket issue. Since it's being spawned here on the ground, because it doesn't have any socket allocated, here in bone name, we could place a socket on the character's hand itself. Right click, add socket. Press F2 to rename. Name it. Shell. Hell no. Shell. Shell eject. F2 to copy. Click on Niagara. On bone name and place it here. And here, in this socket, it originally appears in the character's hand. You just need to adjust it here. I don't really like to follow this kind of method, because if the character's weapon is in a different location, in a different bone structure, anything different, it will spawn incorrectly. But this way, hold on, it will spawn from here. This is the way you can place both the muzzle flash to spawn here in front of the weapon, but as well as the shell, the casing. So, as I said, I personally don't really like this method. I prefer here, where we use the sockets directly from the static mesh, and they will be correctly positioned regardless of the character we use. And this is the final result.
If you liked this video, don't forget to leave a like and subscribe to the channel. Comment below what you thought and have an excellent day.